linear regression. Linear regression we've actually already done back in our equations units. So we should be familiar with how to do that. So it just should be a refresher. And you'll notice in this chart I have both linear and the quadratic regression. So whichever one you're doing, and you may not even know. Sometimes there's keywords in the problem like linear. Sometimes you'll hear line of best fit, or it might say find the linear regression. For quadratic, you might hear the words curve or a quadratic model. But sometimes the problem doesn't even say which it is. So how would you know which one to do? So first, you have to put your data in the calculator. So we'll go through the linear one, and we're going to put this data in our calculator. And here are the directions if you forget how to do it. Whether you're doing linear or quadratic, it's the same directions for putting the data in your calculator. So you're going to go to Stat, and you're going to pick number 1. And then you're going to, if you have data in your calculator like I do, you arrow up, press clear, arrow down, and then go over to L1 and do the same thing, press clear, arrow down. And then we put our X's in under L1. So -2, enter, -1, enter, 2, these are just our X's, 3, 4, and 7. And then under L2, we do our Y's. We make sure we're matching them up. So 1 went with -2, -3, -2, 5, 2, and 6. And if you get behind, you can always go back to your notes and just look. That's the table is right what I have circled. So you enter all those into your calculator. If you didn't know if it was linear or quadratic, you would have to take a look at the picture. So this is how you take a look at the picture. You would go to y equals and clear out any equations, because you may have used it, especially with solving quadratics. You may have put some in there. Then you would press second y equals and number 1. So I'm going to walk you through that on the large calculator. So first thing, I go to y equals and make sure I don't have anything in there. I do, so I need to clear that out. Then I would go to second y equals, that's our stat plot. I need to pick one of these, so I pick number 1. Mine's already on, but, oops, sorry, that went too fast. So I pick number 1, and if it's not on, I turn it on. Like yours right now looks like this. And that means it's off because the solid black is on the off. So I want to turn it on, so see where it's blinking on? I just hit enter, and now it's on. You shouldn't need to change anything else on this screen. It's set up for a scatter plot. It knows to take the X's from L1 and the Y's from L2. That's where we just put it. It's going to make a little box instead of a dot. And my color is going to be blue. If you don't have the color, that's not going to be an option. So once I've done that, I can look at the picture by hitting the zoom. And this is on those directions. And picking number 9 to zoom into the statistics. And then I can take a look at the picture. And you can see from this picture that it is making a line. It's making a line. So that's why I choose linear regression for this one. So how do I do that? Well, if you look back at our notes, the next step is how you're going to come up with your line. So to come up with the line, I have to press Stat. So let's go to our big calculator. Press Stat, go over to Calculate. So you have to arrow over to Calculate, and then you need to look for the one that says Linear Regression, because we've decided it's forming a line, so we're going to pick number 4. It's asking you where to take the X's and the Y's. We don't need to change anything. Just arrow down to Calculate, and then hit Enter, and boom, there it goes. It calculates your M, which is in here, it's your A. It even shows you the equation, y equals ax plus b. And then your b is -0.1793310. So we would just go ahead and round that. So y equals 0.78x minus 0.18. And notice I said to round to the hundredths. Now just to verify that that's correct, if you would like to, you could go ahead and graph it and see if it goes through your data or if it fits it well. So back on our calculator, we would go to y equals, and then we would type that in. Y equals 0.78x minus 0.18. And press graph, and boom, we can see that that line is going right into the middle of all of that data. And it's fitting it beautifully. In fact, if you remember when we did this, we said we should have the same amount of points above as below, and we did. Now, what if it was quadratic? So if it was quadratic, that's going to be the second one over here that's on the right. We're going to put these points in our calculator. So everybody go ahead and put those points in your calculator. So you go to Stat, number 1 for Edit, clear your list out, and then you put your new values in, -2, -1, 0, 1, 2, 3. And then go to our L2 and put in our Y's, 10, 6. Again, you can just look at your paper if you're getting behind or maybe even ahead. And that's how we put our data in. And always refer back to those notes if you have questions, because you can see over here, I did that right there. I put my data into my list. Now, to look at the graph, we already actually have this one set up. So we don't have to go and turn the stat plot on because we did that when we did the line. But we do need to do this first step and erase that equation out of there. So let's go to our calculator, go to y equals, erase that equation, and then go to zoom 9 and see what our data looks like. Now see here how the data is forming like a U shape, or it's almost a V shape, but U would be what it is. So that lets us know that we need to use quadratic regression. So to use quadratic regression, notice we do the same thing. We go to Stat, we go over to Calculate, but we pick the one that says quadratic regression, number 5. Let's go ahead and do that. Stat, Calculate, pick number 5. Again, you got to arrow down to where it says Calculate. Hit Enter. And boom, there we go. And look at the equation. A is the number in front of our quadratic term, B is the number in front of our linear term, and C is our constant. So, taking a look at our notes, writing our equation, again, rounding to the hundredths, 1.39, sorry. Let me erase that. It's not so messy. 1.39 x squared plus 0.21x plus 4.49. Now to double check that one, I can do these steps right here. Go to y equals on my calculator, type in this equation, 1.39x squared plus, was it a plus? Yes, plus 0.21x plus 4.49. And then graph it. And boom, I can see that that parabola is fitting that data pretty well. In fact, again, you can see 3 points above that and 3 points below it. So how do you know when to use which? Well, if you're looking at the picture, you're looking for, if it's linear regression, it looks like it's going to be in a line. But if it's quadratic, you would see it's making a U shape. Notice how there's some symmetry there, which you don't see on the line. And let's do a couple examples. Go on the back. It says, which equation represents this data? Now, this is one that we would have to look at the stat plot. We're going to have to look at it. We already have our calculator set up, so not a big deal. Why do I know I have to look at it? It doesn't tell me linear or quadratic. It doesn't say line or curve. And also, if I look at my answers, there's two that are quadratic, and there's two that are linear. So sometimes I can get a hint if it's multiple choice off of my answers, but these answers are not helping me. So let's go to our calculator. You can flip over to the front if you need to follow the steps. We are going to go to stat, number 1, clear our list out. Then under L1, we're going to put our x's, so -4. Be careful when they're ordered pairs, -3. Sometimes we accidentally, -2. Put in the y's, -1, 0, and 1. And then we'll go to L2 and put in our y's, -4.8, -8.2, -9.1, -8.1, -4.7, and that last one is 0.3. We do want to look at the graph because, like we said, we can't tell that they didn't give us a clue in the question nor in the answers. So I'm going to go to y equals and clear out that equation. Then I'm going to go to zoom number 9 because I already have it set. Now, if I'm looking at that, I can clearly see that that is making a U shape. So I know I want to use quadratic regression. That helps me with my answers. I don't even need to look at these ones because it has to be quadratic. So now I go back to my calculator, look for the directions for finding that. So I'm going to go to stat, over to calculate, pick number 5 because that's quadratic regression. Don't change anything here, just go down to calculate and calculate. And there we go. So we get 1.06, or if you look at the answers, they rounded to the 10th. So 1.1 x squared plus 4.2 x minus, there's the difference, one had a plus and one had a minus, 4.9. So it is answer choice B. And I could check it to see if it fits. You don't necessarily need to do that. If we want to, we want to just make sure it looks like it would fit. We go to y equals, we type that in, 1.1 x squared plus 4.2 x minus 4.9, hit graph, and see how it fits. And it fits pretty good. We can see it's almost connecting the dots there. Lovely. All right, the second one. So going to our second example. This one is asking us to make a prediction when we have an input of 13. Well, to make a prediction, we have to have the equation first. And notice that they gave me a hint here. They said line. So I know I'm doing linear regression because it says find the line of best fit. So back to our calculator. Go to stat. Number 1. Clear out those lists. And under L1, I'm putting my x's, -5, 2, 9, 11, 0, and 5. And under y, I am putting my, or under L2, I'm putting my y's, 9, 31, 143, big number there. 151. That's why it's important to use zoom stat if I was looking at this picture. Technically, I don't need to look at this picture because I was told line. But let's just look at it anyway, just to make sure. So go to y equals, clear that out, hit zoom 9. And see if it looks like, yeah, look at that. I can see it's forming a line. A nice line. So to find that equation, you go to stat, over to calculate. We know we're doing linear regression. We could see that by looking at the picture, which we didn't really need to do because they gave us a hint. Arrow down, hit calculate. And there we have our equation. Y equals 9.79x plus 42.95. So I'm rounding it to the hundredths. And I could put it in there and see if it fits in that picture, but I'm pretty confident that it is a line. If you wanted to, you could go ahead and type that in there just to double check. I mean, especially if it's something where you have time to double check something or to go back and check. You're taking a test and you finish it, you have some extra time, you can go back and check it. And then take a look at the graph and see if it fits it. Oh, sure it does. Look at that. Nice. So let's go back to our notes. So we came up with our line, but we didn't answer the question because you're going to look at those and say, hey, that doesn't answer that question. Because the question is asking you, if I input 13, what would I get out? That's what it's saying. Inputs are our x's. So we're saying if x is 13, what would y be? So I need to put that in there. Y equals 9.79 times 13 plus 42.95. And then you can use your calculator to do that math. So 9.79 times 13 plus 42.95. Let's see what we get. We get 170.22. So y equals 170.22. What's our answer choice here? C. Now there is another way to do this, aside from how we just did it in our calculator. When we graph that, we made a table. So you could do second graph and take a look at the table, which is being slow to come up. Hit it. Second graph. There we go. And I can arrow down to where I see that x is 13. It's lagging a little bit. And when I see x is 13, I can see what y is. Ooh, I went too fast. Sorry. Went too many. Well, you can see there when x is 13, y is 170.22. That's that top one right there. So I can do that too. I can just use my calculator. All right, let's take a look at the next example, number 3. It says, scientists dropped an object from a height of 200 feet. She recorded the height of the object in 0.5-second intervals. Oh, nice hint there, quadratic. So we know we're doing quadratic regression, so that helps us. We don't really have to look at the graph. So let's go to our calculator again, hit stat, pick number 1, clear our list out. Once you do this so many times, it becomes second nature. Oops. Arrow up. That's clear. Arrow down. I'm being faster than it's thinking, I think. Okay. So in L1, we're going to put our x's, so 0. You don't have to put 0.0. 0.5, 1, 1.5, 2, and 2.5. And then for our y's, we're putting those under L2. So we have 200, 195, 185, 165, 135, and 100. Now, if I wanted to just double check it, go to y equals, clear that out, take a look at zoom 9 and see if it does look like it's quadratic. This one's a little hard to see because the numbers are so big, but it is making a curve shape. We're only seeing one side of the curve. Fortunately, even though this one might be hard to tell, they told us. So sometimes when it's hard to tell, they give us a little hint. So we go to stat, over to calculate, pick number 5, arrow down to calculate, hit enter. And there we go. There is our equation. Y equals negative 16.43x squared plus 1.07x plus 199.64. So I like to write that so that I don't forget it. So y equals negative 16.43 x squared plus 1.07 x plus 199.64. Now they're asking us what would be the height at 3 seconds. Well, time, if we notice time is our x, so this is an x. So I need to plug in an x there. Now you have to be careful with this one because we are squaring that 1x, and a lot of times students forget about that. So this is definitely one where I would suggest using that calculator, going to y equals, typing that in, negative 16.43 x squared plus 1.07 x plus 199.64. I could look at the graph. I don't need to. See, it follows that perfectly, which the linear one wouldn't have. This one actually connects all those dots. But what I want to do is go to second graph and take a look at that table and look where x is 3, because that was the input they were asking for was 3. What is y? When x is 3, y is 54.96. So if I look at my answer choices, 54.98, sorry, I said 96, that would be 55. Now number 4, tricky one. And the reason why it's tricky is because of the years. We're never going to put those years into our calculator. They're too large. And we talked about this when we did linear regression. So we have to renumber the years. And notice it says since 2000 or since 1990. So this is going to be 2, 3, 4, 5, 6, 7, 8, 9, 10. Just because the numbers are too big. Now, it doesn't tell me, it doesn't give me a hint on whether to use linear or a quadratic. So I'm going to have to look at everything on this one. So let's go to our calculator. Let's go to stat. Number 1, clear our list out. Under L1, we're going to put our years 2, 3, 4, 5, 6, oops, sorry, 6, 7, 8, 9, and 10. And under L2, we're going to put our y values, which is our active clusters, 22, 24, 27, sorry, I lost my place, 34, 40, 42, 45, and 51, and I missed one. That's where you always got to double check. 22, 24, 20, oh, there was 2 27s. Arrow back up. Missed that second 27. 27. So make sure you're always matching them up, not making that mistake. Or if at the end you have more of one than the other, then that's kind of a hint that you made a mistake. That's what I noticed. Alright, I'm going to have to look at the graph because it didn't tell me linear or quadratic. So I'm going to go to y equals. I'm going to clear that out. Then I'm going to do zoom 9. Take a look at that picture and see. Well, it's definitely forming a line, a very solid line. It's almost connect the dots lineable. So I know that I'm going to be doing linear regression. So stat, go over to calculate, do linear regression, which is number 4. And then arrow down. So there we have our equation. Y equals 3.7x plus 12.47. I'm going to put that under y equals. Because I know the question was asking to make a prediction. So y equals 3.7x plus 12.47. I can take a look at that picture again just to see if it's nice. You can see that it does. It's really nice. If you weren't sure and you did the quadratic, you could do them both and compare and see which one fit better. But this one fits great. And it says, use the equation to determine the number of active clusters since 2015. So our equation, y equals 3.7x plus 12.47. But we're trying to find, if we input year, that's an x, what is our y? Well, 2015 is x equals 15. So that's what we're putting into our equation. Y is equal to 3.7 times 15 plus 12.47. Or, I like to just go to my calculator. Since I put the line in, I can just do second graph. And I can look for where x is 15. I go down a couple because I don't see that on my screen. See what y is. Y is 67.98. And because we're rounding, we'd see all of those were rounded, we would say 68. So for this one, our answer would be y equals 68. All right, you got a couple you-dos. Make sure you look for some clues as to if you're supposed to do linear or quadratic. If there's no clue, then take a look